This next example in the notes allows us to do some comparing of various types of interest compounding. What happens if I only compound my interest one time a year? What happens if I compound the interest every single day? And what happens if I compound it continuously every second of every day? So we're going to look at the same problems, same numbers in every problem, just changing the compounding. In each problem, I have a $1,000 investment. That's my present value. So that's going to go in for P on both of my problems. In each case, I'm going to compound, or I'm going to invest it for 3 years at a 10% annual rate. For our first two examples, just to review, entering our values, this is the amount that we're currently investing. I always have 1 plus my annual rate divided by however many times I'm going to compound it during the year. Then the exponent is however many times during the period that I will actually earn interest. In this case, I'm compounding it 1 time a year for 3 years, so there will only be 3 computations that happen. This is going to be entered in our calculator exactly like we did on the previous page. On the next one, I see I still have the $1,000. I take my annual rate, I divide it by 365 to effectively get a daily rate. The exponent allows me to figure out how many times during this 3-year period I will actually calculate my interest. I'll enter this one in my calculator the same way I did the previous problem. The last one gives us an example of how we're going to use our continuous compounding. We're going to use the PERT formula. We have our $1,000 investment. We don't need to consider the number of times in converting it to a continuous rate because E does that for us. And then our exponent simply takes our rate as a decimal times our entire period. Again, we type this in our calculator. Now, this problem turns out to be a little different when we type it in the calculator because we're going to actually use our E, which we will find on our natural log button. In order to find and raise something to the E to a power, what we're going to do is we're going to find our second natural log button. If I do second natural log, I can now see that I get E raised to some power. I can even use parentheses if I don't want to have to calculate this in my head, so I can do 0.1 times 3. So now I've taken E to my exponent, and I simply multiply that by 1,000. We have to keep in mind our order of operations. The next example, again, allows us to compare different periods. So we're going to look at compounding monthly versus compounding continuously, but on these problems, instead of calculating the amount that we're going to have at the end, we're actually going to calculate how much we need in the beginning. When we read these problems, the way it reads is that we're given a particular investment. It tells us how long we're going to keep it for 10 years, how much the investment is ultimately going to be worth, and how much we should be willing to pay for it. So when it says how much should we be willing to pay for it now, it's asking you to find that present value. Entering all this into my formula, the $1,000 I want at the end, I don't know how much I need right now, that's the point of the question. My annual rate divided by my number of times, so this converts it to a monthly rate, and the number of times I'm going to calculate my interest. When I type this one in my calculator, what I want to remember on this problem is that everything on this side, although the numbers look bad, is actually a number. We can just simply type this in our calculator and take our $1,000 divided by whatever we get here. So when I do that in my calculator, what I'm going to do is I'm going to take, again, start with my 0.08, divide by 12, add my 1, raise it to my power, 12 times 10. This 2.219 is the coefficient effectively on the P. So when I type this in my calculator, I simply need to do 1,000 divided by whatever that previous answer was. And my calculator allows me to recall my answer by doing second, and then I can use my little negative sign. And it tells me, sure enough, $450. I can do the same thing over here, again practicing with my E. Clear this out. Again, I'm going to do second natural log to get E. I'm going to raise that, sorry about that, I'm going to raise that to 0.07 times 10. And now I have my coefficient. I just need to take 1,000 divided by that number. On my last example, this time I need to solve for my rate. When I'm solving for my rate, it's important to notice that the rate appears inside this entire expression. So as I read this problem, I know that semi-annually means that interest is going to be calculated 2 times a year. And this phrasing is interesting because it asks us to double our investment. It doesn't even tell us how much we're investing. It tells us for how long. So what we're going to do to understand how these problems work is we're going to start our problem by assuming that we want to invest $10. So if we're trying to double, then at the end of my investment, I want to have $20. Now, as we enter those values into our equation, what we'll find is something interesting is going to happen. $20 at the end, I start with 10, 1 plus, I don't know that rate, that's what I'm trying to find. Interest is going to be compounded twice a year, and I'm going to have 2 times 5 in the exponent. If I want to solve this problem, the very first thing that I would need to do is divide by that 10. And when I divide by that 10, what I notice is that the left-hand side actually now matches whatever it was that we were trying to do. We wanted to double, so we got a 2. If they asked us to quadruple our investment, we would end up with a 4 right here. To continue solving this problem, again, my r is inside this expression, this term, with an exponent of 10. So I'm going to raise each side to the 1/10th power. When I raise each side to the 1/10th power, I now have 2 to the 1/10th plus 1, or equals 1 plus r over 2. I can subtract that 1. So I have 2 to the 1/10th power minus 1 equals r over 2. And to continue solving, I'm going to multiply both sides by 2. So my final answer is 2 times 2 to the 1/10th power minus 1. And if I type that in my calculator, I will get 0.1435, or converted to a percent, it's 14.35%. Remember, if we're typing this in our calculator, we can type this in from the inside out again. I can raise the 2, and I can actually type in that fractional exponent. I like to press enter after. I can subtract my 1. I can multiply by 2, and I get my final answer.